Day 6 is like day 5, it's just now I'm not telling you where the function is discontinuous or what problem areas to look at. So recall what you did yesterday on continuity, where 1, you had to find f of a, 2, you had to see if the limit exists, so if that's a real number, and then condition 3 was if they are equal, then it's continuous. If they weren't equal, then it was non-continuous. So like I said, today you're not given what x values to look at, and you have to decide. So if it's a piecewise function, we're going to see where we see less than or greater than, and those are going to be my problem areas. If it was a fraction, I would look at the denominator, and the vertical asymptote would be my problem area. So starting with A, it says determine for what numbers x, if any, the following function is discontinuous. So this should have an equal under it, but like I said, you're going to look for any value that is just less than or greater than. So here I see it's less than 0. Here I see it's less than 1. So my two problem areas are going to be x equals 0 and x equals 1. And what we're going to do is we're going to go through the checklist using both of those. So I'm going to focus on x equals 0 first. So the first thing on my checklist is I have to see if f of 0 is a real number. So the debate is, well, what equation do I plug it into? Because technically I have one equation here, which is x plus 2. I have a second equation here, which is just 2. And then I have a third equation here, which is x squared plus 2. So I'm looking where x equals 0. So if I'm looking in my domain part, I see x equals 0 up here. So there has that line underneath it, which means equal to. So to plug in 0, I'm going to use that first equation. So I'm using x plus 2. I'm going to sub in 0 for x. 0 plus 2 is 2. So f of 0 is 2. Next, I have to look at my limit. So since this is a piecewise function, I have to look at the left side, and I have to look at the right side and compare the two. So this is only for piecewise functions. We're going to look at the left side and the right side. So the left side meaning any value that is less than 0. So if I'm looking at my piecewise functions, the domain that said x is less than 0 would be this first one. So I'm going to take a look at the function of x plus 2. So again, it's just a polynomial, so I can just do 0 plus 2, and I get 2 there. To find the limit as x approaches 0 from the right-hand side, so I'm looking at values greater than 0 that lead to 0. So that one would be this second equation, which is just 2. So the limit of 2, well, that's a constant term, so it would just be 2. If you're looking here, I see the left side and the right side are both equal to 2. Therefore, the limit as x approaches 0 is just 2. So for your limit for a piecewise, you got to look at the left-hand side and the right-hand side. If it was just a fraction or a polynomial function, you don't have to look at both. But when it's a piecewise, you got to look at both sides. So then I'm going to compare. Condition 1 was 2. Condition 2 was 2. So both of my conditions are equal. Therefore, f of x is continuous at x equals 0. So now I know at x equals 0 it's continuous. Now I'm going to try x equals 1. So same process, only using a different x value. So if I look at my domains again, I see that this first function is for x, which is less than 0. 1's not even in this domain, so I'm not going to worry about it. So I got equations 2 and 3. So we're going to start off with our condition 1, which says f of 1, and we have to figure out where to plug in f of 1. So we're looking for what domain says equals 1, and that would be this second equation. So my second equation is 2. So f of 1 is just 2. Condition 2 says now I got to look at the limit. However, since I am using a piecewise function, I got to look at the limit from the left side and the right side. So the left side is anything less than 1, and that would be my second equation still because it says less than or equal to 1. So the limit of 2 is just 2. From the right side, I'm looking for any number that's greater than 1. So that would be my third equation, which is x squared plus 2. So I'm going to plug in 1 there. 1 squared is 1. 1 plus 2 would give me 3. So notice how 2 and 3 are not the same number, so they're not equal. Therefore, that limit does not exist because those numbers are equal. And if the limit does not exist, then f of x is not continuous at x equals 1. So just to practice a piecewise function on your own, I'm going to let you do 2. Pause the video now, and then I'll show you the answer key, and then continue on with the notes, and I'll keep showing you the answer key. So try the second one. So for number 2, you're going to have two problem areas, x equals 0 and x equals 2. If you test x equals 0, f of 0, you're using that first equation because that's what equals 0. So you would get 0 there. And then for the limit, you're using the second and first equation to test it. So the left-sided limit is that first equation. The right-side limit is that second equation. If you notice, 0 and 1 are not the same number. Therefore, that limit does not exist. Therefore, this function is not continuous at x equals 0. Then we're going to move on and do x equals 2. So if I'm looking at this, f of 2, I see what equation has it equal to 2. That would be my second equation, so that x squared plus 1. I plug that in and I get 5 as my answer. Then my limit as x approaches 2, I have to use my second equation for my left-hand limit, my third equation for my right-hand limit. When I simplify those, I get 5 for both of them. Therefore, the limit of f of x as it approaches 2 is 5. So since for condition 1 I got 5, since for condition 2 I got 5, they're both the same number. Therefore, f of x is continuous at x equals 2. So for piecewise, you got to look for your problem areas. Now, if it was just a polynomial function, there wouldn't be any problem areas. When it's a fraction, your denominator is your problem area. So I want you to try the rest of the problems on the sheet, and then I'll slowly explain them. So pause the video now and go on, and then come back and check your answers. So for 3, it's a polynomial function, which means it's continuous. For 4, though, we notice it's a fraction. So if we're trying to figure out what x values don't work, we got to do our vertical asymptote. So our two vertical asymptotes are x equals -1 and x equals 4. If I start with condition 1 for x equals -1, I would get undefined, which means it's not continuous at x equals -1. If I plug in 4 for f of 4, I would still get undefined, which means it is not continuous at x equals 4. So therefore, x equals 1 and x equals 4 are not continuous. For 5, I was plug in 0, so f of 0 equals sine 0 over 0. If you're thinking about sine 0, that's like saying sine of 0 degrees, which would just be 0. So again, I would get 0 over 0, which doesn't make sense. Therefore, that one's not continuous at x equals 0. Lastly, pi is just a number, so it is continuous. So if you have any questions, jot them down. If not, try the homework.